students, I welcome you all for our lecture series on food technology. In today's lecture, let us make an attempt to know about the biopreservation and chemical preservatives. Reservoir of enteric pathogens in the environment contributes to disease burden and mortality in population. Enteric pathogens are predominating in sewage manure, polluted water used for irrigation. It is universally accepted that there is no such thing as called zero risk food. Consumers demand food products without preservatives having fresh quality even after storage. Foodborne diseases are among the most serious public health concerns worldwide. In spite of modern technologies, good manufacturing practices, quality control and hygiene and safety concepts such as risk assessment, still foodborne illnesses increased over the past decade. In recent years, there has been a growing interest in the use of natural antimicrobials, especially niacin. Generally, they are active against food spoilage and foodborne pathogenic microorganisms including Bacillus cereus, Clostridium perfringens, Staphylococcus aureus and Listeria monocytogenes. Niacin is a ribosomally synthesized peptide that has broad spectrum of antibacterial activity including many food spoilage pathogens. Niacin works by attaching to the plasma membrane of target cells and create pores in the cytoplasmic membrane leading to cell lysis. So, this episode deals with biopreservation and bacteriocins, classification of bacteriocins, niacin, its properties and applications, lactic acid bacteria and application, and chemical preservation, organic and inorganic. Let us start with the biopreservation and bacteriocins. Biopreservation is a natural and safe power tool to extend storage life and enhanced safety of foods using the natural antimicrobial compounds. Generally, they are of plant, animal and microbial origin and have been used in human food for long time without any adverse effect on human health. In ancient times, honey was used as a food preservative. It works as a preservative because the high concentration of sugar in honey and osmotic activity will take place. This process known as osmosis. The process of osmosis destroys the cells by drying them up. The term bacteriocin is mostly used to describe the small heat stable cationic peptides synthesized by gram-positive bacteria, namely lactic acid bacteria. The use of bacteriocins or bacteriocin producing strains of lactic acid bacteria are of great interest as they are generally recognized as safe organisms and their antimicrobial products as biopreservatives. One of the most common forms of food biopreservation is fermentation, a process based on the growth of microorganisms in foods, whether they are natural or added. These organisms mainly contain lactic acid bacteria which produced organic acids and other compounds that in addition to antimicrobial properties. Coming to bacteriocins. Bacteriocins are antibacterial proteins produced by bacteria that kill or inhibit the growth of other bacteria. Many lactic acid bacteria produce a high diversity of different bacteriocins. Though these bacteriocins are produced by lactic acid bacteria found in numerous fermented and non-fermented foods, niacin is currently the only bacteriocin widely used as a food preservative. Bacteriocins inhibit the growth of similar or closely related bacterial strains. They are typically considered to be narrow spectrum of antibiotics. They are generally recognized as safe substances. They are not active and non-toxic to eukaryotic cells. They are usually pH and heat tolerant. They have a relatively broad antimicrobial spectrum against many food-borne pathogenic and spoilage bacteria. They show a bactericidal mode of action on the bacterial cytoplasmic membrane. Bacterial genera that produces bacteriocins are provided in table 1. Next, coming to classification of bacteriocins. Bacteriocins can be grouped based on their structure and on their mode of action. Class 1 and Class 2A bacteriocins are usually very stable at acidic pH. Methods of classification: Class 1 bacteriocins, Class 2 bacteriocins, Class 3 bacteriocins and databases. Next is niacin and properties of niacin and applications. Niacin is a polycyclic antibacterial peptide with 34 amino acid residues used as a food preservative, and it contains the two uncommon amino acids. The unsaturated amino acids originate from serine and threonine. Regarding its appearance, it is a free-flowing white powder. Shelf life is 2 years at 4 degrees centigrade to 25 degrees centigrade. Niacin is produced by fermentation using the bacterium Lactococcus lactis. In the food industry, it is obtained from the culturing of Lactococcus lactis on natural substrates such as milk or dextrose and is not chemically synthesized. It was originally isolated in the late 1930s and produced since the 1950s as nisaplin from naturally occurring sources by Applin and Barrett Company, used as food additives in USA in late 1960s. Niacin was the first bacteriocin derived from fermentation of a lactic acid bacterium and was approved by the FDA in April 1988 to use in prevention of botulinum spores in pasteurized processed cheese spreads. Niacin is used in processed cheese, meats, beverages, etc. during production to extend their shelf life by suppressing gram-positive spoilage and pathogenic bacteria. In foods, it is commonly niacin is used at levels ranging from approximately 1 to 25 ppm depending on the food type and regulatory approval. As a food additive, niacin has an E number of E234. Since it is a natural antimicrobial peptide, it has been approved as a natural food preservative by more than 50 countries and considered as generally recognized as safe by Food and Agriculture Organization, World Health Organization and the European Union. Coming to application of bacteriocins. Bacteriocins are of interest in medicine because they are made by non-pathogenic bacteria that normally colonize the human body. Loss of these harmless bacteria following antibiotic use may allow opportunistic pathogenic bacteria to invade the human body. They have shown distinct promise as a diagnostic agent for some cancers. Bacteriocins were tested as AIDS drugs around 1990 but did not progress beyond in vitro tests on cell lines. Bacteriocins can target individual bacterial species or provide broad spectrum killing of many microbes. Applications in meat products, that is a bacteriocin producing culture for sausage fermentation and or biopreservation. Pediocin PA1 or ACH is more suitable for use in meat and meat products than niacin. Niacin is non-poisonous, natural and effective as antiseptic in food. It is used in powdered form which is greyish white or yellowish in color. It remains stable under the condition of acid heating and at room temperature. Stability of niacin mainly depends upon three factors. They are storage length, incubation temperature and pH. Its antimicrobial spectrum reveals that niacin can stop or kill gram-positive that can turn the food putrefactive. It works well against bacterial spore that display tolerance towards Bacillus acidophilus. Niacin preservative also inhibits various other bacteria such as Bacillus cereus, Clostridium botulinum, Bacillus stereoacidophilus and Listeria monocytogenes. The niacin lipid 2 complex penetrates the cell wall and breaks into the cytoplasmic membrane and form pores. Through these pores, the internal cytoplasmic content oozes out, resulting in bacterial inhibition or death. It does not make any changes in the working of normal community of bacteria in the intestine, neither it causes drug resistance to antibiotic substances. It also has not shown resistance to antibiotic drugs. Coming to applications of niacin. Niacin is popularly used in dairy products, milk, aquatic products, poultry, meat products, plant protein, fast food, baking food, fruit juice, canned food, cosmetics, beverage drinks, healthcare products and medicines. It helps by decreasing the time taken for sterilization, lowers temperature during food sterilization, improves food quality, lessens damage to nutrition and prolongs storage time of food material. For regular use, 5% of niacin solution made by dissolving in pure water is mixed in equal amount of food by using grading extension technique. Sometimes other types of antiseptics are also used in combination with niacin. So the question is, what are the food categories in which niacin is used? The food categories in which niacin is applied are as follows. First one is dairy products. In this category, niacin is used as preservative for increasing the life of yogurt, natural cheese and processed cheese. The further categories of processed cheese including block cheese, spreads, dips, sauces and slices containing varying amount of moisture content. These contain emulsifying salts and are processed by heating. Processed cheese also comes with additives and flavors such as shellfish, herbs, fish, etc. Flavored processed cheese requires use of niacin in different measure for extending the shelf life. The next category is egg products. Egg products like yellow, whole or white are treated to heat temperature for kill Salmonella species. Next is pasteurized soups. There are many heat resistant bacteria that do not get eliminated during pasteurization. Hence, niacin is used in pasteurized soups for preventing or delaying the cycloduric activities of food spoiling bacteria. Next category is flour based products. Flour based products do not have long shelf life, even though it is toasted before serving. Heat resistant bacteria do not get killed. There have been instances of food poisoning due to crumpets in major part of Australia. So, as to stop the growth of Bacillus cereus, the crumpets or any other flour based products, Australian and New Zealand government has approved to use of niacin. Coming to canned food. Use of niacin for preventing thermophilic spoilage has been made mandatory in most of the countries. Although low acidic canned foods are exposed to heat during packing, so as to guarantee their shelf life at normal temperature, use of niacin is permitted. Since thermophilic spores are very sensitive to the combined treatment of niacin and heat, this preservative is used preferably with heat treatment. Some of the canned foods that contain niacin are okra, baby sweet corn, asparagus, potatoes, peppers, carrots, peas and mushrooms. For canned foods with high acidic product like a tomato, more amount of niacin is used. Next category is meat products. Earlier, nitrite was used as preservative in meat products, but at present it has been partially replaced by niacin. It is used in cooked sausages and low fat sausages. Next is seafoods. Niacin is used more in smoked salmon as it acts as highly effective anti-listeria agent, especially when the packing is done in a carbon dioxide atmosphere. Salad dressings. In salad dressings, the acidity level is reduced to retain the flavor during cold dressing. But this reduction in acidity leads to growth of bacteria. This spoilage is controlled by using niacin. Next category is alcoholic beverages. Lactic acid bacteria that are acid tolerant have a tendency to spoil wine and beer. Since yeast does not get affected by niacin, it is usually added during the fermentation process. Niacin is further added to fermenters for preventing contamination in unpasteurized beers for increasing shelf life. After niacin, now we shall focus on lactic acid bacteria. Lactic acid bacteria refer to a large group of beneficial bacteria that have similar properties and all produce lactic acid as an end product of the fermentation process. They are widespread in nature and are also found in our digestive systems. Although they are best known for their role in the preparation of fermented dairy products, they are also used for pickling of vegetables, baking and wine making, curing fish, meats and sausages. Additional characteristic flavors and aromas are often the result of other products of lactic acid bacteria. Coming to the production of lactic acid. Lactococcus lactis originated from the lactic industrial products have been still extensively studied for their commercial potential, but that strain isolated from plants has been given less attention in sugar mills. Lactococcus lactis, like many other lactic acid bacteria, are involved in producing lactic acid. Next is application of lactobacilli in dairy industry. Lactic acid bacteria, especially lactobacilli, are responsible for the formation of the microflora of most dairy products, especially of cheese and fermented milk. Lactobacilli are important for flavor, color and texture of dairy products through acidification due to lactic acid and of the metabolism of milk proteins. The most commonly used species in dairy products are Lactobacillus casei, Lactobacillus helveticus, Lactobacillus rhamnosus, Lactobacillus lactis and Lactobacillus curvatus and Lactobacillus plantarum. Furthermore, lactobacilli are incorporated into yogurt, cheese and fermented milk as probiotics due to their beneficial effect, especially on acute and chronic inflammations of the gastrointestinal tract. Addition, due to the production of bacteriocins, lactobacilli also help on the preservation of dairy products. Move on to application of lactobacilli on wine industry. Lactobacilli are also applied in wine industry both for grape and fruit wines such as cider. The organic acids existing in wine, which are mainly malic and tartaric acid, can be easily metabolized by lactobacilli. Malic acid is converted to lactic acid and carbon dioxide. This phenomenon is called malolactic fermentation, which is extensively used for fruit wines maturation. Though tartaric acid is decomposed into pyruvic and citric acid, complete spoilage of the selected food products occur. So, the appropriate choice of the fermenting lactobacilli is necessary. Usually, decomposition of tartarate is observed by Lactobacillus plantarum and Lactobacillus brevis. Next is chemical preservation, organic and inorganic. Chemical food preservatives are substances which under certain conditions either delay the growth of microorganisms without necessarily destroying them or preventing the growth. It includes some natural food constituents which, when added to foods, it prevent the growth of microorganisms. Sugar is used partly for this purpose in making jams, jellies and marmalades and in candying fruit. The use of vinegar and salt in pickling and of alcohol in brandying also falls in this category. Some chemicals are added to foods to prevent the growth of microorganisms. The latter group includes some natural food constituents such as ascorbic acid or vitamin C, which is added to frozen peaches to prevent browning, and a long list of chemical compounds fall into foods and classified as antioxidants, bleaching agents, acidulates, neutralizers and stabilizers. Organic chemical preservatives. Sodium benzoate and other benzoates are among the principal chemical preservatives. The use of benzoates in certain products in prescribed quantity, that is usually not exceeding 0.1%, is permitted in most countries, some of which require a declaration of its use on the label of the food container. Since Free benzoic acid actually is the active agent. Benzoates must be used in an acid medium in order to be effective. Benzoic acid is more effective against yeasts than against molds and bacteria. Other organic compounds used as preservatives include vinylic acid esters, propionates, sorbic acid and glycols. Next is inorganic chemical preservatives. Sulfur dioxide and sulfides are perhaps the most important inorganic chemical preservatives. Sulfides are more effective against molds than against yeasts and are widely used in the preservation of fruits and vegetables. Sulfur compounds are extensively used in winemaking, and as in most other instances, when this preservative is used, much care has to be exercised to keep the concentrations low in order to avoid undesirable effects on flavor. Oxidizing agents such as nitrates and nitrites are commonly used in the curing of meats. Sodium benzoate and benzoic acid. The two are related because sodium benzoate produces benzoic acid once dissolves in water. It has got antimicrobial properties. Most effective on low pH below 4.5. Sodium benzoate is used in fruit products, beverages, dressings, salads and pastries fillings, icings on olives. It works against yeasts, molds and some bacteria. Low levels were used to avoid off flavor and maximum level allowed by law is 0.1%. Next one is potassium sorbate. Sorbic family includes potassium sorbate, sodium sorbate and calcium sorbate. Potassium sorbate will produce sorbic acid once it dissolves in water and is widely used preservative in the world. Effective against yeast, molds and bacteria. Effective up to pH 6.5, maximum level allowable by law is 0.1%. In many food products, sorbate and benzoates are used together for greater protection against wider variety of microorganisms. Benzoate effective only below pH 4.5, but sorbate is effective even with a pH 6.5. Preservative are used in foods must be declared on the list of ingredients on the label along with short explanation of its use. Pickled meat. Meat may be preserved by dry curing or with a pickling solution. The ingredients used in curing and pickling are sodium nitrate, sodium nitrite, sodium chloride, sugar and citric acid or vinegar. Now, it is time to conclude this session. Biopreservation refers to extended storage life and enhanced safety of foods using the natural microflora and or their antibacterial products. Lactic acid bacteria have a major potential for use in biopreservation because they are safe to consume and during storage they naturally dominate the microflora of many foods. Lactic acid bacteria are therefore excellent ambassadors for microbial world. They are not only of major economic significance but are also of value in maintaining and promoting human health. Niacin is currently recognized as a safe food preservative in approximately 50 countries. Niacin is an extremely stable product. Biopreservation reduces the amount of chemical preservatives as well as the intensity of heat treatments. Niacin remains the most commercially important bacteriocin, although other bacteriocins have been characterized and developed for possible approval and use. The most common food-borne infections in the European Union are caused by bacteria, namely Campylobacter, Salmonella, Listeria and viruses. They are reported to affect nearly 4 lakhs of European Union citizens each year. Students, I hope you have some useful information in this episode. Thank you so much for watching this session. Keep watching our lecture programs. Hope we will meet in the future episode. Until then, take good care of yourself. Bye for now.